So today, I want us to look at, in this lesson, I want us to look at the equations of tangents, and normals, equations of tangents and normals to a curve, equations of tangents and normals to a curve. So we'll be looking at these two types of equations, that is equations of the tangents to a curve and also the equations of normals to a curve. And we are going to start with the tangents. We'll start with the equations of tangents. The equations of tangents. Now, when we have a curve, for example, a curve like this one, and we want to find the gradient at a point, and gradient at a certain point, let's say at a point, we can call this one point P. When we want to get the gradient at point P, we need to draw what we refer to as a tangent. A tangent is a line that will pass through that point. It is a straight line. When we talk of a tangent is simply a straight line that will pass through the point given, that will pass through the given point, such that if we want to draw the tangent to this point here, because we want to get the slope or the gradient function of this curve, this is the curve, this is our curve, we want to get the gradient of the curve at point P. And therefore, you just come and draw a straight line that will only pass through that given point. So that will pass the horizontal line passing through that point only. So we have it this way. And therefore, this is our tangent. We can call this our tangent. This is the tangent. So when we want to find the gradient of the curve at point P, the gradient of the curve at point P, we simply come and get the tangent, and then we find the gradient of the tangent. So gradient of the curve at point P is equal to the gradient of the tangent. The gradient of the tangent. So by getting the gradient of this tangent, we'll be in a position therefore to get the gradient of the curve at that point P. So can do some examples on how to calculate the equation, how fast we can get the gradient, then we get the equation of the tangent to a curve, equation of the tangent to a curve, that is at a certain point. So we have seen that when we are getting the equation of a tangent, we need first to get the gradient. And for us to get the gradient of the curve at the point, we need to draw the tangent, which is a straight line passing through the given point only once at that point. So the gradient of the curve at this point P is equal to the gradient of the tangent. And therefore, we want to know how we can get the equation of a tangent to a curve when we are given an equation. So like in this example here, we are told find the equation of the tangent, find the equation of the tangent to the curve. We have been given the curve y is equal to x cubed plus 2x plus 1 at the point 1, 4. So those are the points, that is the point that we have been given, and we are told to find the equation of the tangent to the curve. This is the equation of the curve at point 1, 4. This is the coordinate of that point. Just like we can have a point here which is point P here. So our point P is 1, 4 at a point 1, 4. So we have to find now the equation. And before we get the equation, for us to get an equation of the line, because it is a straight line, it is an equation of a straight line because it is a tangent, the equation, we need first to get the gradient. We need first to get the gradient of the tangent. The gradient of the tangent. That should be the first thing. We need to calculate the gradient of the tangent. And therefore, we have the equation of the curve. Y is equal to x cubed plus 2x plus 1. So when we want to find the gradient, we first get the gradient function dy dx. That will give us the gradient. So we need to differentiate this or to find the gradient function. So we have 3 multiplied by the coefficient of x, which is 1. So we'll have 3x. Then we have 3 minus 1. Then plus x here is raised to power 1. So we have 1 times the coefficient, which is 2, x 1 minus 1. And then this is a constant. And we say that the gradient function of a constant is 0. So we have a 0 here plus 0. So our dy dx will be 3x squared, then plus 2x raised to power 1 minus 1 is 0. And therefore this one becomes 1. So we are going to have plus 2. So that is the gradient function. And we are told it is at 0.14. So this is the value for x and this is for y. So we have dy all over dx, which is equal to this. And therefore, we need to calculate now the actual gradient, the gradient, so that we can use now the points. So we have that dy all over dx is equal to 3x squared plus 2. So we can get the gradient because we have the point at 0.14. So we have x, y. So we can come substitute the values of x with 1. So we are going to have our dy all over dx, which is our gradient, to be equal to 3. Our x is 1. So we have 1 squared, then plus 2. So we are going to have 3 times 1 plus 2, that is 5. So our gradient is 5. So that is the gradient of the curve at that point, 1, 4. So we can simply come and say that our m, which is the gradient, is equal to 5. And we have the point we have is 1, 4. So we need to come and get the equation. From the equations of a straight line, when we want to get the equation of this tangent, because it's like we have the curve here, and then we have our point, and this point we have the tangent here. This is our tangent, and we have this point. Let's say here we have a point 1, 4. So we can come and get another point on the tangent. We can call it x, y. So we are going to have point 1, 4 and another point x, y. And we know that the gradient is equal to 5. And we know gradient m is given by change in y divided by the change in x. So in this we are going to have the change in y, which is y minus 4. So we have y minus 4 all over the change in x, which is x minus 1, is equal to the gradient, which is 5. A whole number is always over 1. Then we can close multiply so that we can get the equation. So in this case, we are going to have it this way. So when we close multiply, we have y minus 4. We are multiplying all of it by 1 is equal to x minus 1. We are multiplying that by 5. So we end up getting y minus 1 is equal to, we open the bracket, 5 times x, we have 5x. Negative 1 times 5, we have minus 5. And therefore, we have, this is what we have. for the equation of the tangent, and the tangent is a straight line, so we expect the equation to have the form of equation of a straight line. So we have y minus 1 is equal to 5x minus 5. So we can write it in the form y is equal to mx plus c, which is the equation, this is the equation of a straight line. So we'll simply come and say we have here y is equal to 5x minus 5. Then we take 1 to the other side, we have plus 1. So y is equal to 5x then minus 4. And this is the equation of the tangent. This is the equation of the tangent at the point 1, 4. And we can see clearly from this equation, we can see clearly that y is equal to 5x minus 4. This is an equation of a straight line. And we know that the general form of an equation of a straight line is equal to y is equal to mx plus c. Meaning that this is our gradient. And we can see clearly that our gradient is 5. And there's somewhere where we calculated the gradient as 5. So we can confirm that it's okay. So, and the y-intercept, it will pass through negative 4. So this is the equation of the tangent. So I repeat, whenever you are given such, find the equation of the tangent to the curve. This is the curve at this point. The first thing is to get the gradient function. The gradient, so the gradient function, and our gradient function, we simply differentiate. So when you differentiate, you get the gradient function. Then after getting the gradient function, we require to get the actual gradient at the point 1, 4. And therefore, since we have, this is the gradient, therefore, and we have point 1, 4, for x we have 1. So we come and substitute x with 1. So we are going to have the gradient as 5. Number that is 5. Then after getting the gradient and we have the point, we can now come and get the equation. Because we know when we have the point, we get another imaginary point xy. We have the gradient that is 5. And therefore, gradient is change in y all over change in x. And therefore, our change in y, we have y minus 4. So this xy is an imaginary point. It is another point on the tangent. It can be on this side, on whichever the side. So it is a point again on the tangent. So we know very well that gradient m is given by change in y all over change in x. Our gradient is 5. Then we have change in y, y minus 4 divided by x minus 1. Then we can close multiply and get the equation in the form y is equal to mx plus c, which is the general equation of a straight line. And therefore, our equation for the tangent is equal to y is equal to 5x minus 4. And that is the equation of the tangent.